My name is Adeline Parent. I'm the chair of Geothermal Community in EAGE, and I am very happy to welcome to you first webinar of the year. And yes, I do know that we are already in May, but good things come to those who can wait, right? So trust me, today's presentation is worth the wait. As well, Maria said, we are going to dive into the fascinating world of the geothermal exploration, and we will be focusing on the Ukrainian side. So can you do the next slide, please? So this is the agenda. I'm not going to dig into that. So next slide as well. So first, let's give a shout out to our amazing geothermal community. So I promise this introduction won't be boring, hopefully, because we are a dynamic network of members who are passionate about sharing the latest breakthrough trending topics, integrating case studies, and innovating application of the geothermal realm. So wherever it is, either shallow or deep, for the heat or for the power, conventional or unconventional, we hope to be on the topic. And our community is all about cross-pollinating ideas from various subsurface technology and putting our expertise to jointly exploit geothermal energy along with other resources. It's like the geothermal thinking tank where creativity meets science. And today we are all part of it in these splendid webinars. So next slide, please. So let's kick things with the virtual high five to our community so you can see them on the screen. We managed to get the pictures of everyone. Hooray! As you can see, we are quite spread in Europe. So if you wanted to join our community and you are outside of Europe, feel free to contact us and we will be happy to add you to our committee. Next slides. So we are trying our best to propose activities like dedicated session for the EAGE annual or for the EAGE Get coming soon. We are developing a webinar series like the one today. PS, I am looking for people to present, so feel free to contact us and we will be happy to add you to this webinar series. And we regularly are posting LinkedIn news, career advice, or vacancies. So again, you are free to join us. Also, please take your phone right now and you can scan, if you do next slides, please. You can scan this beautiful QR code with this beautiful logo we created. So this is our Geothermal Energy brand. And this QR code gives you the access to the LinkedIn page of our geothermal community. So I give you like 1 second to, take a pictures of the QR code. You can request to join. The group is private, but we add everyone who is willing to, come and join our community. Next slide, please. So as you can see in the upcoming EAGE annual in Toulouse in France, which is in 2 weeks from now, we have 3 dedicated sessions that is coming from the Geothermal Committee. And we have 2 the first day of the conference, which is Geothermal Energy in France, a game changer for accelerating decarbonization. This is in the morning. In the afternoon, the same day, we have advances in geothermal carbonate reservoir characterization. And then on the last day of the conference, we have challenges of repurposing an oil and gas well to geothermal well. And I hope to see you for these 3 dedicated sessions, which I believe will be fantastic because we worked very hard on it. Next slide, please. So I would like to mention as well the upcoming EAGE workshop on geothermal energy in the Middle East, which, by the way, will happen after the EAGE annual on the 22 to 24th of June. But the call for poster are still open, so you still have 10 days to submit, and I hope you will do so because I think it will be quite interesting. Fortunately, I will not be there because I have other things to do, work related, but I think it's a big miss. So if you can make it, please tell me how it went. Next one. This one is the third EAGE workshop on geothermal energy in Latin America. I actually hosted, did a welcome speech on the first one, the first EAGE workshop, and it was really, really great. And it takes more and more space, so I do believe that's a nice one to attend as well. The call for abstract deadline is on the 1st of August 2025, so you do have time for that. So again, you should definitely submit some of your papers, especially for EGS. Next slides. This is the famous GET, EAGE GET, which the four community are participating, which is wind, geothermal, CCS, and hydrogen. And this time, again, as you can see, the deadline for abstract is still open until the 15th of June, so you have 1 month. But the conference will be still in Rotterdam like last year, which was actually fantastic. And it was very well received, so well that we're actually returning to the Netherlands, and the conference will be from the 27th to the 31st of October. Next slides. This is this, thank you for joining our first webinar series. And next slide is actually the beginning of the presentation. So let me introduce you to Roman Petrokushyn, a geophysicist who is making waves in the world of energy exploration. He has over 6 years of experience at the international company SLB. Roman has an act of uncovering the secret of the earth. Just, sorry. He's like a modern day Indiana Jones. But instead of searching for lost artifacts, he's delving into seismic and geological wonders for fuel of the world. Roman Adventures has taken him across more than 10 countries. Can you imagine already? Where he's tackled everything from oil and gas project to geothermal field exploration and even undercover gas storage. His expertise is as deep as the Earth's crust, and his insights are sure to illuminate the complexity of our planet resources. In addition to a professional journey, Roman is also a dedicated scientist, and he has a bachelor and a master degrees. He's currently working on his PhD dissertation at the same time as working. Congratulations on that. Focusing on geothermal potential screening on this intriguing Carpathian Foredeep. And it's safe to say that Roman's passion for science is as intense as geothermal hotspot. But wait, there is more. Roman is also an active member of our EAGE Geothermal Committee, as you saw it previously. He's contributing to the advancement of the field by sharing his knowledge with his fellow enthusiasts, like today for these webinars. So buckle up for an engaging session as Roman shares his experience and insights. Let's give a warm welcome to the geophysicist extraordinaire, Roman Petrokushyn.
Thank you very much, Adeline. That probably is the best introduction I've ever gotten in my life.
I hope so.
Good. Thank you very much. Hi, everyone. I don't think I need to introduce myself anymore after that beautiful introduction from Adeline. But as mentioned, my name is Roman Petrokushyn. I am a geophysicist who is based in Ukraine, in Kiev. And today I want to present to you the topic of how we apply potential field data, so our gravity and magnetic data, for geothermal exploration. And I will be explaining that on the case study that I'm doing as part of my PhD for Ukrainian Carpathian Foredeep. So we don't need to go into my introduction anymore, but what I want you to know is that my part of the job, which has been for 6 years in SLB, I've been doing most of the work in seismic interpretation and geological modeling. So I'm not really working with gravity and magnetic data that much. And what I'm doing here is something new for me. And I'm really used to nice seismic data. I'm used to 3D data. I'm used to even 4D data, seismic data sometimes. But this time, when I started doing my PhD in the University of Kiev, I decided that I need to work on something better and making the world a little bit better place. by contributing my knowledge of geoscience. So this is what I decided. I decided to apply my knowledge into the geothermal. And it turned out that my skill set of doing the seismic interpretation is great, but when there is not so much seismic data, I have to find a way to make use and create something with my geoscience knowledge. So a little introduction of geothermal energy and the importance of it, and overall this story of what I'm going to be sharing with you today. So the story I'm going to share with you today is basically going from huge scale to smaller scale and then to detailed scale. So when we talk about geothermal, we know that this is a reliable source. This is the sustainable source. It can produce 24/7, doesn't matter if that's winter, summer, if the day is stormy or if it's windy. We know that geothermal can produce 24/7 every day. What we also know is that the untapped potential for geothermal is huge. Depending on which data we're looking for, some people say, like Geothermal Energy Association, saying that this is around 7% tapped potential. Other sources might say that this is less than 1% tapped. So what it brings me is that if we look at this map on the bottom, we do know that we have these hotspot areas. We do know that we have these subduction zones, and some of them are very well studied, like the ones that we have around Gulf of Mexico, in California, in Europe, in Italy, in Indonesia. But when you look at these batches of red for the hot temperature zones, and you look at these points where you have existing geothermal power plant locations, you do see that the points are very well smaller than the zones. And if we look at where we have Ukraine, in Ukraine we have 0 points. So my goal is to start with 1 point and then increase the number of points for geothermal power plant locations. So what, why, and how? And the presentation about today is about these three questions: what I want to do, why am I doing it, and how am I doing it? So as I mentioned to you, my goal of PhD was to get to create a geothermal potential atlas. Why do I need it? Also, this is something that I mentioned, is that I decided that based on my petroleum industry experience and also my knowledge of geoscience, I know that I can apply what I know to make a world a little bit better place. So why is it needed? It is needed for screening, ranking, and exploitation for the geothermal resource that will give us cleaner energy, alternative source of energy that might help make a world a little bit a better place. So the question is, how do we do it? How do I create a geothermal potential atlas? And this is the question that I asked myself when I started my PhD. The overall answer is pretty straightforward. You take your geological data, you take your geophysical interpretation, you combine them, and then you do your techno-economical assessment or resource assessment. And as I said, I'm a seismic interpreter. I'm a geophysicist who focuses mostly on seismic interpretation. And I was hoping very much that I would be working with the seismic data. But once I've started looking into the area and into the basin that we have, from the open source, my geophysical data looked like this, and it made me feel like this. So after spending a couple of days looking through seismic like this, and seeing relatively nothing, and by the end of the day, I was just seeing stripes, not my family, not my friends, but stripes of poor seismic data. So this is the moment when I decided that if I don't have seismic data, I should have something else that could help me out create this geothermal potential atlas. So this is why I welcome you to my talk about potential field data. What I will be explaining to you and what I will be sharing with you today is the potential field data and the application of gravity and magnetic surveys for the geothermal exploration for the screening stage. So for the big scale analysis for the basin, to understand where we have the geothermal potential, where we can explore and dig a little bit more to get the geothermal, to convert this potential into something exploitable into the heat in place, and then use that either for heating or for power generation. So as a geophysicist, whenever I'm presenting, the first conclusion that I have is that geology comes first. So anytime I'm presenting about geophysics, I will start with geology because geology should always come first. So this is a nice image of Europe, and this is a nice image of Ukraine. Ukraine has many things. We have mountains, we have sea, we have rivers, we have all the landmarks that you can imagine. And when we're talking about production for, let's say, for hydrocarbon, we have three zones, one in east, one in the south, and one in the west. So when we look into the west, in the western area of Ukraine, we have mountains that extend through Czech Republic, Slovakia, Hungary, Romania, which are called Carpathian Mountains. So we have this nice ridge, and on the northeast side of that ridge, we have Ukrainian Carpathian Foredeep. And this is the area that I'm focusing on for my area of study, for my geothermal potential exploration. So what is good about working with this area is that it has been a oil and gas center for quite a while. We had the first ever oil fields in Europe opening in this region. It's a young region, it's a young Foredeep basin for Neogene, Paleogene. What else do we know about it is that it has a sandy shale formation, which poses as a reservoir for hydrocarbon, for oil and gas, but not only for oil and gas, but as well as for hot water, based on several drillings, and we have up to 200 wells, which prove, which give us the information about depth and temperature. Some of them give us information that there is a temperature up to 120 degrees, about 3 kilometers. So the question that I'm asking to myself, can I use that, and can I use these point information and then convert them into something more mappable, more explainable, rather than just having one point and extrapolating from the one point? So this is where we start talking about geology. And if we build a little section that goes from point A over here to point B over here, so from southwest to northeast, we're going to go through mountains, where we have our mountain range, our Carpathian Mountains. And as we go to the northeast, we're going to have a foreland basin. So this is the area, this is the schematic area of where we're working. And now if we look into the structure of it, if we look through the cross-section, this is another cross-section from the paper that I found a pretty nice one. This is how our foreland basin looks like. So this is a brief introduction of geology, of where we're working with, and a little bit of taste of what do we have and what kind of data are we working with. So a little bit about study dataset. I mentioned to you, and I've shown to you slightly before what kind of seismic I had. So the decision was that seismic was very poor quality, and there is some coverage of seismic on very small located fields, which I will use further. But if I want to do the regional screening, basing range screening of geothermal potential, I should be using something that has a better coverage, and that is my CBA, my complete Bouguer anomaly map, as well as my magnetic anomaly map. So here you can see a point set of data for gravity measurements, which was acquired from early 80s to early 2000s. So it's not very new. We can call it legacy. It's been 30 plus years since it has been acquired, but it has been proven to be very useful for the sake of this study. So except for magnetic and gravity data and seismic data, as I mentioned, I have around 200 wells for depth temperature pairs, and I have my heat flow map from previous studies from 90s. So when I plot my depth temperature pairs, these are wells where I have depth and the temperature. The question is, why do I see them like this? Why do I see them in kind of linear manner? And why do I have no hot temperature right next to the cold temperature? What is going on? So this is something that I'm raising as a concern, and this is something that I have to answer And that would be basically the question of my PhD. So we know the geothermal source, the source of the hot rock, or the source of the temperature in geothermal system either comes from the mantle uplift, or we have a subduction zone, or we have the closeness to lithospheric asthenospheric boundary. But we're not, the zone that I'm in, we're not in the subduction zone. We're around 200 meters from 200 kilometers from the subduction zone. So based on some workarounds and some previous studies that have been done on the region, we do know that the continental shelf that was in here is a relatively stable one. And what we do know, when we have a stable continental shelf, we might have something happening like you can see here on the image on the right, where we have the uplift of the mantle and the moho closer to the surface, not exactly where we have the subduction, but a bit further to the side. And this is something that we have been seeing in the region. So the question is, how can I use it, and how can I map it, and how can I see it? And the answer is by looking through my gravity and magnetic data. So what am I looking for? I'm going to be looking for my moho and basement character. I'm going to be looking also for the folds that might be behaving as a fluid pathway, or the inducer of the fracturing that could induce the fracturing and increase the porosity of these fold zones, and would be the fluid migration from the hot rocks at the bottom to the reservoir zone at the top. And lastly, but not last but not least, right? I want to create a cross section through my zones of interest, so through these hot zones, to understand what is actually going on in the cross section. And all these steps will be done through my potential field data analysis. So what I will be sharing with you today are 3 approaches that I've done, and 3 approaches that have been proven very useful. First is lineament extraction for the reservoir zone from gravity data. Second is, how can we estimate where is our basement, and how does our basement communicate with gravity data and deep drilling? And lastly, how can we create cross sections through the zones of interest to understand and to do the forward modeling to understand what kind of structure do we have, and how does the gravity and magnetic response correspond to our geothermal task. We'll start off with the lineament extraction for the reservoir zone. We know that gravity data is not only a map of gravity. We know that the gravity corresponds to the spectrum of the measurements. So if we do the Fourier transformation of our gravity data, this is on the top left, we have our full Bouguer anomaly. And if we do a spectrum spread, let's put it this way, we can see that we have three ranges. We have a low range, we have a mid range, and we have a high range. So these high, low, mid, and high ranges of wavelength, they actually tell us of how does the wave have traveled through the subsurface, and also they are telling us a little bit about the depth of where we're seeing these or that features. So my task is to see where do I have folds that extend to my reservoir zone that can be either a fluid pathway or the increase of the fracturing or the fracturing zone. So I want to focus only on my reservoir zone, which is going to be around my mid range. Sorry. So this is why I'm doing the bandpass filtering, and then I'm running the TDR, the tilt derivative analysis. Tilt derivative is known for highlighting discontinuities, for highlighting the change. So if we're seeing the polarity change on the tilt derivative, it can tell us about the presence of the folds or fractures. Once I've done that, I've mapped my lineaments. But of course, I should always honor geology, and I should always honor what has been done previously. And this is what I do. So I analyze the previous maps that have been created, and this one is created based on the geological state service of the pre-Cenozoic sequence. So my reservoir zone. And then I compare the map, the Rose diagram of one, and the Rose diagram of the second one. So what I see is that there is a perfectly nice match between the one and the other. But what else I know is that geological state service maps are limited to the amount of data that it has been used based on the drillings and based on the available seismic sections. So based on the analysis that I do, we know that some faults over here are not actually faults, but are assumed faults. So what I'm using my gravity data for is that I can prove and I can use not just the geological analysis, but also my gravity analysis to understand where do I have these faults. So once I have faults, I will use them in the next step. I am calling that a win because I already have the lineament extraction. So the second approach we're doing is to understand where do we have the basement. And basement evaluation is something that we usually do for gravity and magnetic inversion jobs. And now in my data set, unfortunately, the magnetic data was not very prominent in terms of the response based on the old acquisition parameters, but it was good for forward modeling. So in my case, I'm not really able to do the inverse job for the inversion for the basement. But what I can do is to analyze the bandpass and the bandpass that I was just showing you earlier for the low frequency to see how do I see the resemblance between what we know before, what is the legacy study, what is the drilling, what was the deep drilling, and what's the seismic interpretation, and how does that communicate to my gravity? So this is the example of what we have. On the left, I have the map, the previous study map for the deep drilling and seismic interpretation that I digitized. So you can see that the basement that we have extend from 2 kilometers to around 25 kilometers with a mean of 11 kilometers, more or less. And once you see my bandpass complete Boolean anomaly map for the low wavelength range, you can see that there is a nice resemblance between the one and the other. Now, what I am going to use this for is I'm saying to myself that, okay, my gravity data shows me the deeper section. It can contribute not just for the reservoir zone, not just for the topsoil, but also it has some information for the bottom part. And all this analysis of the basement evaluation based on gravity and the lineament analysis, I'm taking these two parameters, and then I'm going to use them for the gravity and magnetic forward modeling. So gravity and magnetic forward modeling is a very important step in my case because I will be using that to actually map or do the cross sections through the zones of interest and to understand what is happening not just on the map sites, but also on the cross-section size, going from 0 meters on the top to 40, 50 kilometers to understand the big story. So the data that I'm using for my gravity and magnetic forward modeling is, of course, my gravity and magnetic, but also for the deeper zones, I'm using MOHO depth based on LithoRef. I have some literature cross-sections that you can see here that goes from the west to the east, so through here, from point A over here to point B over here. And actually my zone of interest are these. So the yellow is the reservoir zone, and these verticalized faults are actually the faults that I'm looking for and the faults that I've found based on my lineament. So what I'm planning to do and what I'm doing is actually using my literature analysis, so from my previous understanding of geology, and I'm trying to match my my geological understanding to the response of gravity and magnetic. So I start off building with the same section as I just shown you, and if we look through the geological section that we just built, the magnetic and the gravity does not correspond. So we see on the top over here, this is my gravity response on the points and the straight line. This is how the gravity would respond if I have this section. So if I go with the geological section before. The same goes for magnetic. You see that the synthetic response that I'm modeling does not communicate to the actual measurements. So the actual measurements are at the points, and the response is, the synthetic response is the straight line. So the next step is to actually match the one and the other, because maybe the geological analysis that was done before is not really that precise. They have not used gravity and magnetic. So once I've added a little bit of analysis that I'm seeing from lithograph, for example, I see this a little pull up of the moho based on the lithograph. I also see that I might have some intrusions and some faults, which I'm seeing from my lineament analysis, that would contribute to my gravity response and to my magnetic response. And if I zoom in into my zone of interest, which you can see here from 0 to 10 kilometers, this is actually something that is very, very interesting, because what I see in here are my red zones, are my hot zones, and I see a fault, I see the pull up of moho, and I see the reservoir zone that is crossed through this fault. So this is very important to me, and this is let's say a starting point to build upon the story about geothermal potential screening that I'm going to do as next steps. And the beginning point of my work is actually to take the map of the faults. Where do I have my faults presence? The ones that I've extracted from the lineament plus geological analysis. Then the heat flow map that is present from the previous study from the 90s. Add the aquifer presence that I'm also taking from the literature, and add the basement that I just acquired from the analysis from a priori basement evaluation based on my gravity data. So I'm not only using the existing geological analysis or existing geophysical interpretation, but where I see gaps in the understanding or the gaps of the basin scale screening, I'm filling them up with the potential field data analysis. So by end of the day, what I am going to have, and I'm still working on that because I'm still need a few maps to be generated, and this is something that is still work in progress. The end result of my potential field data analysis plus geological analysis and some geophysical analysis would be a geothermal potential atlas once we look into everything together. So faults, the presence of the faults, fault permeability, mantle uplift, basement, aquifer presence, heat flow, and thermal conductivity would contribute to the global picture of what I call the geothermal potential atlas. And once I have that, we can go and talk about techno-economical analysis, find some spots that we see have higher priority or higher chance of success, and then add some seismic temperature logs, create 3D models, and then run the heat in place estimation. So with that, I'm going to go to conclusions and acknowledgements, and then I can see some questions in the chat, so we can talk about them in a second. But first of all, the first conclusion that I'm doing is that I do love Lord of the Rings, and there's this wording, all we have to do is to decide what to do with the time that is given to us. In my case, all we have to do is to decide what to do with the data that is given to us. In my case, I don't have beautiful data. I've shown you the seismic that I've been working with. And that doesn't mean that if you don't have the data, this is the moment where you stop. You can always use your geological maps. You can always use your previous analysis, and you can always use gravity and magnetic. So this is the point number 2. Gravity and magnetic, even legacy data, are perfect for big scale screening. They're perfect for understanding the geology. And you don't need to have nice advanced measurements, accelerometer measurements, or high magnetic resolution, magnetic susceptibility measurements. If you're just starting and you don't have anything, gravity and magnetic are a big, nice place to start. But again, knowing how to use and where to use gravity and magnetic should always come first from the geology. Geology is always key. You need to understand what you're looking for. You need to understand where the geothermal source, where's the geothermal kitchen, where it is coming from, so that you can apply your geophysical knowledge to get the geology out of it. And the last thing is the more data you have, the better results you're going to end up with, and more chance of success, less risk, less uncertainty. So that brings me to my acknowledgements. First of all, I want to thank these people on the screenshot, sorry, on the slide, Giuseppe, Luciana, Adeline, who are working and helping me a lot by mentoring me. So Giuseppe and Luciana helped me a lot from GeoSolution side to get understanding of how to work with gravity magnetic. Adeline is still helping me out to understand a little bit on how to work with geothermal. So thank you guys for that, as well as my advisor from the University, Metropis Rodney, and of course, Geothermal Energy Committee for inviting me, for letting me be the first speaker for this webinar series. So thank you very much. I think we can go for the questions if you have. Yeah.
Thank you, Roman. So I'm going to read the question that is on the chat because they arrived during your presentation. And then after, we're going to open the floor for people that either want to actually say hi and, talk out loud and give you the question directly. So first question was from George Basta. He was asking that from your presentation, you are investigating the formation like the oil and gas exploration. Just want to make sure he understands it as you presented. So the workflow that you use is mostly oil and gas based, yes?
Yes, correct, George. You're right. And the reason for that is because this area is drilled with the wells that have been used for oil and gas. So we could start working with the area where we have no information, but if we have the information for the wells that have been drilled for oil and gas, that's a good starting point. Not only because of having the data, but also because of the reason of having the wells drilled, and then in the future, the possibility of repurposing these oil and gas wells into the geothermal wells.
Okay. Now we have another question which is related to the data. You use gravity and magnetic data sets. And so they wanted to know the source of the data. So that's the first question. The second question is it related to ground or airborne? And finally, if it's ground, do you have any idea of the type of equipment used?
Mm-hmm. Yeah, thank you. Yeah, so for source of the gravity and magnetic, the data set has been given to me by my academic advisor from the university. The source of it is the airborne gravity measurements, not accelerometer measurements, but gravity measurements, and as well as magnetic. As far as I know, this is airborne, and it has been acquired a long time ago in the 80s and 2000s. And so, unfortunately, there's no information in terms of the processing sequence or some information about the acquisition reports. That is what we know. So definitely not ground measurement, but airborne measurements.
Okay. So now finally, I have the last question on the chat, and then another one. Okay, so another question. Michael, how did you establish the density of your rock for gravity forward modeling? That's such a good question. And what about the velocity for depth conversion?
Okay, thank you, Michael. Right, so for density for the gravity forward modeling, I've been using the LithoRef models and the Geosoft datasets. So Geosoft actually have very nice datasets, not just for the depth of the surfaces, but also their assumed densities. So when I'm talking about the shallower zones, so the zones of my reservoir, I was using the information that was available locally, so either through logs or through the well measurements. But when I'm talking about MOHO, when I'm talking about the basement, the magnetic susceptibility and the density have been used based on LithoRef and based on Geosoft density maps.
Okay, so Bastian is asking, are the data from the oil and gas wells available for further analysis of the geothermal potential? So is it open source?
Yeah, for now, as you know, the war in Ukraine is still ongoing. So the oil and gas wells are a proprietary data, and it has been closed. There was a time in our lives when the oil and gas data was open and was also open for the investors. At the moment, the data is closed. You can see it on some databases as well, like we've seen on S&P Edding, or I think Restart as well have that. My hope is that once the war is over, we're going to publish that, and we're going to be open for the investors and for anybody who want to start working in geothermal. And one of the reasons of my PhD is I'm not doing my PhD for some closed entity. I'm doing that as independent PhD student who will publish all my studies available, and then you can reach out to me and talk to me in the future. So once this is we're going to have this ban removed. I hope this information will be published and will be available for future analysis. That would be my hope.
Fantastic. George is the person who asked the first question. He's asking another one. Do you have source heat rocks and the same model of heat migration, heat transfer, like oil and gas perspective? And if yes, what is criteria to confirm geothermal reservoir can be developed?
Okay, thanks, George. So the concept, the idea of heat presence, this is something that I've been mentioning on the first couple of slides, is based on the previous analysis of the data, plus understanding of what kind of geology, of what kind of tectonics we used to have back in the day, back in the when the basin was formed. Now, in terms of understanding of the heat transfer, this is something that I'm still doing. I'm still will be modeling that actually in Petromol to understand how does the heat transfer, how does that migrate, and including the fact that faults would be actually the heat transfer, the migration transfer, because what I do know is that the geothermal reservoir can be developed because we do know that the faults are open systems based on geochemistry studies from the oil and gas, because there are some studies saying that these faults have that there are migration pathways from the deeper zones which have hydrocarbon kitchen, and then the faults are open based on geochemical studies, and then they are formed into these shallower reservoirs. So this is under the scope of concept that I'm having right now. But once I have the results once I do the due diligence of mine in Petromod and basically going back in time, I should prove that as well.
Right. So we have a question, which is a political question, and here I'm going to add something. EAGE is not a political platform. I'm going to read the question, but you are not supposed to answer it. It is absolutely up to you to do it. So, will your great work be influenced by the raw materials deal between Ukraine and the US?
Thank you, Carlo. To me, I'm not working in politics. I'm not working for the government or any of the governments. As I mentioned, this study is a PhD student study, and it's working basically on almost the open data or open source data. So I don't see any interference with any deals in the political scale. As I mentioned, my hands are clean. I'm open, and all the results that I'm showing to you. First, this is going to be available in YouTube, and then the end result of my PhD should also be available for anybody interested in that.
Great. Is there anyone that has a question that wants to unmute themselves and ask the question directly? We have another question on the chat in the meantime. From Can again. I don't know the first name, so I'm sorry about that. Do you think a new potential field, magnetic gravity data set, acquired using modern equipment, sensor, accelerometers, magnetometers, would be more useful than older data sets using old technology for modeling in your domain?
Definitely yes. Not just potential field data, but also I mentioned there on some slides. Magnetotelluric measurements are perfect for having that for geothermal, because we can talk about resistivity, and having faults speaking with resistivity are actually very, very, very well. Definitely having more modern equipment measurements would benefit, but it's also the question of coverage, because if we have coverage of modern equipment just on some local small field, that wouldn't be sufficient enough to talk about big scale or low wavelength that would reach for the basement. I think merging them, let's say the modern equipment, the high resolution studies, merging them with something like we have here on the legacy, and maybe even some satellite images, some satellite imaging from NASA, might be a good idea if you want to go from big scale to lower scale. I think I didn't answer one question about the main conversion, velocity depth conversion from Michael. I was just reading that. Regarding the velocity, Michael, you asked me, what about the velocity for depth conversion? This is again still a study that I'm going to do a little bit later, but I've created a regional velocity model that would help me to convert seismic from time to depth. I do have a couple of VSPs that I'm using for regional analysis, for regional conversion. But if we're talking about this big conversion from, first couple of meters up until 40 kilometers, 40, 50 kilometers, for that I'm using as well. As deeper I'm going, the less data I'm having, I'm using analog data.
Thank you. So again, some question. Does anyone wants to unmute and then ask the question directly, or we still have 9 minutes before we close the webinars for questions?
Hi, Roman, it's Mike again. Thanks for the answers on the velocities and the density. I guess, do you know why your seismic data looks so bad? Is it acquisition and processing, or is it the underlying geology, which means, seismic just isn't viable in this part of the world?
Yeah, so it's it's a couple of this and a couple of that. The only data for the seismic I have are legacy 2D. Some of it's just scanned and digitized. The one that I was just showing you, this one was not scanned. This is a SegWide data. And one of the reason is because, yes, if we're looking at in this structure, having seismic data, having nice seismic data from this zone, even if it was acquired in the 80s, 90s, would be a very, very big stretch. But we do have some newer acquired 2D data, newer acquired even 3D data, but I don't have 3D for my PhD. So that is something that I'm planning to do, and that is something that I will be using for what I'm pushing here, the techno-economical estimation. So once I have my geothermal potential atlas, and I might choose a couple of potential fields here and there, and then do the heat in place estimation. And over there, I will be creating the 3D model based on the seismic data. So I already have one field for which have 2D seismic data coverage, and it's relatively good. But again, this is small, it's localized. But that is something that I would be using.
And do you have velocity data associated with that better seismic data that you could use to kind of supplement your other velocity data?
Yeah,
sometimes when the signal's still bad, you can still get something out of the velocities, I guess.
True. For that, there are no velocity analysis, there are no velocity cubes. Again, I will be using mostly VSPs, doing a little bit of well tie where I can, and then converting everything to depth based on my VSPs.
Great, thanks.
So we have time for one final question, and then after we are going to close the session. We have Prince Will. Do you have a flowchart that one can follow to replicate similar study and processing elsewhere? Because I have access to gravity and magnetic data, but only use Oasis Montage, Geosoft. But if I can get a step-by-step, it will help a lot. Your work is so clean, maybe because your seismic processing experience, I would love to produce a result of multiple methods like you do to get better information.
Yeah, you made me blush, Prince Will. Thanks a lot. I don't actually have the flowchart. You can always reach out to me in LinkedIn. I can help you as much as I can with what I know, right? For gravity and magnetic data, having Oasis Montage is perfect. Is more than enough. Everything that I was doing here and I was showing to you was done in Petrel. But if we're talking about having, I think Oasis Montage is also a nice software that can do these things for you. Now, in terms of achieving this or that result, it will always depend on what kind of basing you are, on what kind of situation you are, because you know that with gravity and magnetic you can answer multiple questions. The gravity and magnetic is the multi-answer tool. It always depends on what you're looking for. In my case, I was building up a story where I have my geothermal kitchen because of the old continental build up based on the subduction. So I was looking for the mantle uplift, and I was looking for the faults that would actually go to this mantle uplift. In your case, it might be different. So if I was working, let's say, in the subduction zone, my approach would be different. So again, the flow chart would be slightly different. But you can always reach out to me. We can talk a little bit more. So for that, I always thank Giuseppe and Luciano who guided me.
All right, so I thank everyone for coming and listening to this beautiful presentation from Roman. And we are still looking for presenters. So if you want to join and do a presentation for our webinar series for geothermal, feel free to reach out. Thank you very, very much. We are closing the session. Maria, do you want to add anything? Or even actually, Romain, do you want to add a very last point?
Just thank you very much for everybody coming here, and thank you Geothermal Energy Committee for having me. Thank you.